Hello everybody, I would like today to introduce one of the post hoc tests, which is the Fisher's LSD test. The LSD is the abbreviation for the least significant difference. This type of post hoc test can be applicable for both equal sample sizes and different sample sizes. Today I will introduce the equal sample size to adopt this type of post hoc test. Okay, let's examine what we have here. In the middle we have the one-way ANOVA table, which is already filled after pre-calculations, and these calculations comes from the data regarding four groups: group A and group B and group C and group D. So we have four groups, and the sample size for all the four groups is the same. It is 5. So the sample size is 5. And regarding the average for each of these groups, it's already included here. For group A it's 5.2, for group B it's 6.8, for group C it's 3.6, and for group D it is 7. As we see in the one-way ANOVA table, the value of the statistic F, or sometimes called the calculated value of F, is greater than the value for F critical. So there is a significant difference between the means for the four groups. What is needed in this question is to conduct the Fisher's LSD post hoc test to determine the significance status between the four means. The value of the significance level is 0.05. So this is the question needed. So first, let's have a look at the formula for the LSD test. As I mentioned earlier, we have two cases for the LSD test. We have LSD test for different sample sizes, and in this case we use the formula in the above. The value of the LSD, or least significant difference. First we get the value of T by knowing the value of the significant level and the degree of freedom for the error or within. This is multiplied by MSW, which is the mean square within, multiplied by 1 over Ni plus 1 over Nj. I and J represent the sample sizes for group I and group J. So this is the LSD formula for different sample sizes. In case that Ni is the same as Nj, which means that we have equal sample sizes, the formula we are using to calculate the value of the LSD is the below one. So LSD in this case, we have a value of T, and this is multiplied by root square of 2 times mean square within divided by N, and N in this case is the sample size for one of the groups. So for my presentation for today, I'll talk about the equal sample sizes, so we will deal with the bottom formula. we can conclude that the LSD formula for equal sample sizes is a special case for the general case, which is in the top. So we can consider the top formula to be the general one, and a special case where the sample sizes are equal, we use the bottom one. So what's the criteria in order to use the LSD? Actually, we are comparing two values. The first value is the absolute difference between two means. For example, for two groups, we get the two means for the both groups, and we get the absolute value of the difference of the two means. And we compare this value with the value we get from the LSD test. So in case that we have the absolute value of the difference in the two means is greater than the value of LSD, in this case, we conclude that there is a significant difference between the two means. Otherwise, if the absolute value of the two means, of the difference of the two means, is less than the value of the LSD, then there is no significant difference between the two means, and in this case we consider the mean for the group I, which is x bar I, to be the same as the mean for group J, which is x bar sub J. So this is the criteria in order to make a decision regarding the significance or non-significance between two means. So this is the data for the LSD test we need to calculate. As I have mentioned earlier, we have four groups, group A and B and C and D, and all of these groups are of 5 observations or 5 replicates. So we have the case of equal sample sizes, and we have different means for the four groups. So we need to check for the significance or non-significant between each pairs of these four means. But before starting the calculation, let's count for the number of paired differences or the combination which comes from the four groups. So the formula for the number of paired difference is equal to K times K minus 1 divided by 2. K represent here the number of groups. So we have four groups. So if we substitute in the formula, we get the number of pair difference, which is equal to 4 times 4 minus 1, all divided by 2. So if we proceed in the calculation, so we get the last value for the number of paired differences to be 6. So we have 6 pairs of means for the four groups, and these 6 means are the following. The first one is group A versus group B. The second one is group A versus group C. The third one, group A and group D, group B and group C, group B and group D, group C and group D. So we should calculate the absolute value 6 times for each of these 6 pairs in order to check for the significance or non-significance between the means of these 6 pairs. So let's calculate the difference or the absolute difference between each of these 6 pairs. First, let's calculate for group A versus group B. The absolute mean difference is the absolute difference between x bar for group A minus x bar for group B. And if you check for the top table, here x bar A, it's 5.2, and here x bar for group B is 6.8. So absolute value of 5.2 minus 6.8, which is the absolute value of minus 1.6. And always in mathematics, the absolute value for a negative number is the positive one. So 1.6. The same for group A and the group C. The absolute mean difference, x bar A is 5.2, while for group C it's 3.2. So the absolute difference for the two means is 1.6. Same like the above one. Regarding the third pairs, group A and group D, the absolute value of group A minus the mean of group D. This is the mean for group A and this is for D. So the absolute is minus 1.8, which is 1.8. If we follow with the same technique, we get for the rest. For group B and C, the value or the difference between these two means is 3.2, while for group B versus group D, it is 0.2, and for group C versus group D, it is 3.4. So as we see in this slide, we have 6 pairs of groups, and the difference between the means for each group has been calculated. So we need to compare all of these 6 values with the value of the LSD. We will calculate LSD one time only, and then we can simply compare. Okay, let's calculate for the value of the LSD or the least significant difference. The formula for LSD is equal to the value of T for significant level, which is alpha by 2, and degree of freedom for the error or within, and this value of T is multiplied by the root square of 2 times mean square within divided by n. The mean square within, it's already calculated in the one-way ANOVA table. It is simply, it's 2.55. And regarding the value of n, which is the sample size for one group, it is 5. So the rest, in order to get the value for LSD, is to get the value of the T from the T distribution. As noted from the question, the value of the significance level alpha is equal to 0.05. So we need to calculate for the value of T for significant level of 0.05 divided by 2 and degree of freedom within, which is equal 16. The value 16 is the degree of freedom for the error, or sometimes called within groups. So it is 16. So first we need to find the value of the t at 0.025 significance level and degree of freedom equal to 16. So we can simply refer to the t distribution table and check for the significance level, which is 0.025, and degree of freedom equal to 16. This is the t distribution table. Of course, the 0.05, the significance difference, the significance level, sorry, it is for the two tails. So we need for 0.025 for one tail. And regarding the degree of freedom, which is this column, we check for the degree of freedom, which is equal to 16. So the intersection between this significant level and the 16 degree of freedom, it is 2.12. So this is the value of t. So the value of t at significant level 0.025 and degree of freedom equal to 16 is equal to 2.12. So simply now we can calculate for the LSD by direct substitution. So this is the formula. All what we need in order to calculate for the LSD now available. This is the value of t. It is 2.12. This 2 is constant. 2.55, it is the mean square within, or the mean square for the error. And the value 5 is the sample size. Sample size for one group. So simply if we proceed, we get the value for LSD to be 2.14. So this is the value of the Fisher's least significant difference. And in order to compare, we will compare this value of LSD with the 6 pairs. So as we mentioned earlier, we have 6 pairs. Let's start first with group A versus group B. The absolute difference is 1.6 in the pre-calculation, and this value is less than the value of LSD, which is 2.14. So we conclude that there is no significant difference between the mean for group A and the mean for group B, which means that the two means are the same, which means x bar A is the same as x bar B. Regarding the second pair, group A versus group C, it's the same. The absolute difference in the mean is the same. So it is less than 2.14. Again, there is no significant difference between the two means for these two groups. So we conclude that x bar A is the same as x bar C. Regarding the third pair, the absolute difference is calculated to be 1.8, and again 1.8 is less than 2.14, which is the value of LSD. So again, there is no significant difference between the means for group A and group D, which means that the mean for group A is the same as the mean for group D. The 4-pair, which is between group B and group C, the absolute difference between these two means is 3.2. And 3.2 is greater than the value of the LSD, which is 2.14. So we conclude simply that there is a significant difference between the mean for group B and the mean for group C, which means that X bar for B is not the same as X bar for C. Which one is the bigger? Is it X bar for group B or X bar for group C? We simply can return back to the table in the above for the means for groups B and C. For B, it is 6.8, while for C, it's 3.6. So the mean for group B is greater than the mean for group C. So right now, we find one significant difference between two means. Let's check for the 5-pair, which is between group B and group D. The difference is 0.2, which is less than 2.14. So we don't have a significance between the mean of group B and the mean of group D, which means that the two means are the same. And finally, let's check for the last one or last pair, which is between group C and group D. We see that the absolute difference is equal to 3.4, which is greater than 2.14. So in this case, we have a significant difference between the mean of group C and the mean of group D, which means that the mean for group C is not the same as the mean for group D. And if we check for the table in the above, the mean for group C is 3.6, while for group D it is 7. So X bar D is greater than X bar for group C. So this is simply how we calculate for the significance between each two means in each group. So in order to make a summary and make a quick revision for what we have done right now, this is what we have of data. This is the one-way ANOVA table, and all the records are there, and these are the groups and their statistics. So we have 6 pairs. We have 6 pairs because we have 4 groups. We have 6 pairs. For example, A versus B, the difference is 1.6, and this is the value of LSD, it's 2.14. So there is no significance. Same like pair A versus C, there is no significance, and A versus D, while for B versus C, the absolute difference between these two means is 3.2, and 3.2 is larger than 2.14. So we have here a significant difference. Regarding B versus D, there is no significant difference. And the last pair, which is between group C and group D, we see that the absolute difference between the two means is 3.4, which is greater than 2.14. So we have a significant difference. So as a conclusion, we have 4 non-significance between the 4 groups or 4 pairs, while we have 2 significant cases for 2 pairs only. These are all the calculations that we need for this question. But first, let's mention some features for the Fisher's least significant difference test. As we see here, the value of the LSD 2.14 is significantly greater than the value for the difference for other tests. For example, Bonferroni, the value of the significant difference will be greater than 2.14. So in this case, we say that this test, which is an LSD test, is a liberal test, which means that it is very easy to have a chance in order to reject the null hypothesis, simply because the value of the LSD is not that big value. We will talk later about the Bonferroni and compare that type of post hoc with this one, which is the Fisher LSD. Thank you. If you have any comments, please write it down. Goodbye.